The recent release of new images from NASA of the interstellar visitor known as 3I Atlas has sent ripples through the astronomical community. And the picture it paints is disturbing. What was first hailed as a rare cosmic visitor now appears to be a far more complex, potentially volatile object than initially understood. The visuals reveal an object behaving in ways that challenge existing models of cometary behavior, forcing scientists to reconsider just how normal it is, and what that might mean for our understanding of such interstellar wanderers. Before we start, smash the like and subscribe buttons for more updates. We see more than 7 jets that are tightly collimated coming out of this object. They might be thrusters on the technological spacecraft. The discovery of 3I Atlas in early July 2025 by the Asteroid Terrestrial Impact Last Alert System Telescope network placed it firmly among a very select club. Only the third confirmed interstellar object ever recorded. From the start, its hyperbolic trajectory and extreme speed marked it as something of an alien guest in our solar system. But the latest images show that this visitor is not merely passing through quietly. It's actively transforming, shedding material, altering structure, and exhibiting behaviors that appear to intensify with each observation. One of the more striking features in the latest set of imagery is the collapse or disappearance of a clear tail. A recent article reported that 3I Atlas appears to have lost its tail altogether in new frames, a phenomenon that defies the usual timeline of a comet's behavior as it approaches the Sun. This suggests that the object is undergoing structural changes, perhaps fragmentation or rapid shedding of volatile material in a way we do not fully understand. When a comet loses its tail prematurely, it signals that either the source of the dust and gas is being disrupted or the geometry and viewing angle have shifted so dramatically that what we expect to see is no longer visible. In addition to the tail loss, the NASA-released images show an expanding coma, the diffuse envelope of gas and dust around the nucleus that seems to be growing at an unexpectedly rapid rate. According to an AP News-type release, the coma was seen to widen and the activity increase as the object comes closer to the Sun. The mere fact that an interstellar object is showing conventional comet activity is itself remarkable, but that this activity is not proceeding in a textbook manner adds to the mystery. The expanded coma, coupled with diminishing tail, might indicate that the material being released is finer or in a different configuration, making the tail less prominent or scattering differently. Another key revelation from these newest images and accompanying data is the unusual composition and behavior of the object. Infrared and spectroscopic studies by telescopes such as the James Webb Space Telescope have shown that 3I Atlas is dominated by carbon dioxide outgassing with comparatively low levels of water vapor, which is quite distinct from many comets that enter our inner solar system. Moreover, polarimetric observations have revealed extreme negative polarization at small phase angles, meaning that the way light is scattering from the coma is unlike most known comets and even shares characteristics with distant trans-Neptunian bodies, rather than typical solar system comets. These findings hint that 3I Atlas may originate from a very different environment than anything we have directly sampled before, and its internal structure or composition may be far less stable. From a visual standpoint, the new images capture a ghostly, diffuse object that seems to be shedding layers, perhaps crumbling or releasing material in bursts rather than continuously. The contrast between a broadening coma, weakening tail, and the spectral oddity suggests that 3I Atlas is undergoing some form of breakdown or transformation. That is what many refer to when they say it's getting worse, not in the sense of danger to Earth, but in the sense of its structural integrity or stability. If an interstellar object breaks apart or fragments, it opens a Pandora's box of possibilities for how such objects behave once they enter a new star system. One major implication of this is that we may need to revise our assumptions about how interstellar comets survive passage through a host star's environment. For typical solar system comets, heating by the sun leads to sublimation, tail formation, and predictable outgassing patterns. But here, 3I Atlas is providing a case where the behavior is erratic and perhaps much more extreme. The intense CO2-driven outgassing noted implies a reservoir of volatile ices, preserved in deep cold and suddenly exposed to the inner solar system's warmth, causing violent responses. It raises the possibility that many interstellar objects may carry far more volatile inventories than familiar comets. And when they approach a star, they may behave in ways hazardous to themselves: fragmentation, explosion, and complicate observation. Another implication touches on the origin of such objects. If 3I Atlas is so different in composition and behavior, it suggests that the processes forming comets and icy bodies around other stars may diverge significantly from what occurred in our own solar system. The high CO2 to H2O ratio, for example, could point to formation closer to ACO2, ice line in another protoplanetary disk, or exposure to a higher radiation environment in its parent system. That means when we think of comets as frozen leftovers of solar system formation, we may be seeing only a small subset of what such objects can be. Interstellar visitors might bring with them chemistry and structure unimaginable from our paradigm. The fact that NASA decided to release these images now and emphasize the unusual developments also tells us something about the urgency of the situation. Observational opportunities for interstellar objects are fleeting. Because 3I Atlas is on a hyperbolic escape trajectory, we have only one pass, one chance to observe it in detail. And if the object is breaking up or changing rapidly, the time frame for capturing meaningful data is even shorter. Timing is critical. These images are a call to the community. This is not business as usual. We are witnessing something unpredictable evolving before our telescopes. Beyond scientific insight, there is a psychological and philosophical dimension to what these images evoke. Seeing an object from another star system, one that arrives unannounced and exhibits behavior beyond our expectation, challenges the sense of familiarity we have with space. We like to think the laws and categories we rely on are universal. But when something comes that doesn't quite fit, when it behaves worse than expected, meaning more extreme, more volatile, less stable, it forces humility. It reminds us that our sample of space phenomena is tiny, and that there may be a vast variety of objects out there, with histories and makeups radically unlike our own. In practical terms, the way these images change how astronomers plan future interstellar object campaigns is significant. We will likely need to build protocols for catching such objects earlier, tracking them more aggressively, and mobilizing multiple instruments across wavelengths quickly. The fact that 3I Atlas is producing large amounts of CO2 gas and showing unusual polarization suggests that instrumentation tuned for solar system comets might miss key signals of interstellar visitors. In other words, our playbook for comets might require a rewrite. Observing such objects may demand a broader toolkit and readiness for surprising behavior. The new images also raise the question of what lies downstream for 3I Atlas. If it is fragmenting, then debris could spread along its orbit, creating trails of dust or small particles. While none of the released information suggests any danger to Earth, the orbit is well understood and the object poses no impact threat. The shedding of material might produce dust streams or meteor-like phenomena if intersecting Earth's path. It's not a blockbuster risk, but it's a reminder that interstellar visitors might introduce new sources of material into our solar system environment. Moreover, the evolution of the object's tail, the coma size, and the outgassing profile may affect its brightness and detectability, which influences whether amateurs or smaller observatories can continue to monitor it.